gave me feedback about 2 NASA things she used, and as well as the JPL one. So for now, let me just give you a little preview before I introduce Claire and let her give you the exciting overview of the mission from an intern's perspective. But March 13th is dedicated to hearing about orbital debris and space trash. It is something that often my students are fascinated with, but I am for sure, because these are historical pieces, inactive satellites. Some of them could be fixed, some of them are rocket parts. However, they are a matter to deal with, and there's something that we need to consider before we start a mission. So Dr. Mariba Jah, his last name is Jah, he is the co-founder of a platform called Wayfinder. He is an incredible spirit and steward of the earth. He has a TED Talk. So I think I will put in the chat once our meeting gets going, his name, so you can look it up in advance. But he will be speaking on March 13th to our group, and I have developed 5 or 6 different activities and tools to go with his platform. He has given me support to use them, and he's excited about our mission. So I can't wait for you to meet him. So without anything further, I'll come back on again after Claire. I would like to introduce Claire Toia. She's been on these meetings. She's been an intern with us for a year. She is our main worker right now on the hot development of our CAD model, which is prototyping one of our designs. She will talk to you about the mission using those parts. And I really think that we get richer and stronger when we teach and tell about what we think we know, and then we learn in a deeper way. So Claire, this is your time. Thanks for doing this tonight. I'm going on mute.
All right. Hello, everyone. I'm glad so many people could be here. I'm going to be going over the parts of our project, the actual physical parts, and then I'm going to show you some CAD designs and how you can add logos to things, but that comes later. So I'm going to share my screen real quick. Can everyone see it? Or I hope, can you guys see it? Yes? Okay, cool. So like I said, I'm going to be going over the parts and then the CAD as a quick intro. The original basis of the idea we're working on was CubeSats, which are about 4 by 4 by 4 inch cubes or 10 centimeter cubes that can be brought up into space and then released. And so it's a small satellite. It's much more accessible for students to use or create. And my old school, Bishop O'Connell, where Mrs. Pore is, we did one while I was there, or maybe the year before, but we did one. Our idea, though, is to make it even more accessible. We want to be able to send up more satellites all at once. So the idea is, instead of having 4 by 4 by 4 cubes, we're going to have a 4 by 4 square that's about ½ inch thick. And those are the SlimSats. That's what you guys would get to work on with your students. You would get to program the circuits, or you can try to decide what you guys want to collect data-wise. We're still working on creating those, but eventually that would be what you guys would be working on with your students. So as an introduction to some of the parts, we have the outside portion. This is called a pod launcher, usually, as you can see in the figure 5 main pod features. So this is what would be attached to hopefully the ISS is what we're aiming for. And there's a door, and eventually, whenever we would program it or set it to release, it would release the 3U satellite that would be inside, which is this. On the right, you can see a 3U satellite, which 3U is 3 CubeSats long. So our full product is going to be about, I think, a little over 13 inches. So you can see on the right, we have the 3U with a tuna can on the end. And then on the left-hand side, you can see that circular hole. That would be where that tuna can looking thing goes into. And there's a spring that's attached to it. So when it's time, the 3U satellite would get released out of the pod launcher. And inside of the pod launcher, we have the SlimSats. Again, that's what you guys would be working on. You can see the small square over here in front of the 3U satellite. That is a representation of the SlimSat. And then the gray box behind it is the representation of the 3U satellite. And this is the files that I have been working on. It's pretty similar in shape to what I've showed you on previous slides. On the left, in the yellow, is the pod launcher, or at least a representation of what our pod launcher is going to kind of look like. So that, again, would be attached to the ISS or whatever satellite we end up going with. And inside of there, that's where this red 3U satellite would go, and then the red one would get released out of the yellow one. And then I have another picture showing a little bit more about the SlimSats. These are the things that would get sent to you. The idea is there's no circuit boards on this slide, but the idea would be there's circuits on them with sensors. So you can do data collection of GPS, RMF radio, a couple other things. It depends what sensors and circuits we get on there. But the idea is a nut would get embedded in there somehow, and we have a long rod, and each SlimSat, as the rod spins, each SlimSat would move forward, and eventually once it hits the end of the rod, it would come off the rod, and that is when the SlimSat would be released, and it would go on its own orbit, and it would start collecting data. So this is another photo of the SlimSat. This is what we're currently working with, the model idea we have. I also have a printed version here. I hope you can see it. I can't see my camera right now, but you can see there's a area for the nut to go into, and then on the right, you can see that where the nut would go. And again, there'd be a rod going through it, which is what this shows. So imagine that there's a bunch of these SlimSats with a bunch of nuts. There'd be in total for the 13-inch product, I think there'd be about 20 or so. But this is just an example of how it would sit on there. The rod would rotate, it would move forward, and eventually release. This is another look at everything all together, minus the rod. I did not add the rod in this model, but there would be a rod going through all of those individual gray SlimSats. Here's a photo of what it would look like if it were releasing. Again, there would be a rod. And that is the end of the presentation I have here, but I will be going. Does anyone have any questions about this stuff specifically before I get into the CAD stuff? You can also ask questions later on when we have the breakout room. But if there's no burning questions, I'll move on to the CAD.
Claire, while you're moving on to the CAD, I want to make a comment on your incredible work. She modeled the parts that are actually like the brass and steel parts, and you're able to get these files and print them and secure them together to get the full idea of the build. All right, that's all I wanted to say.
Yes, that is a good addition. We will be, or I will be, uploading these files to a Google Drive that Garth created, and you guys should be able to print them from there. I'll talk more about 3D printing very soon. The files come in half sections because printers, especially the ones that we have access to, aren't big enough in order to print a 13-inch long thing. I see a hand raise, so I'll take that question and then I'll move on to the CAD.
Thanks, Claire. First of all, wonderful job on the CAD. I was just curious, what is the current thickness of the SlimSat?
The SlimSat is about it's half an inch, modeled to
Half
be
an inch. Okay.
So
Thank
we
you.
can fit a lot more of those inside the 3U than if we had 3 1U CubeSats.
Thank you.
Okay, thank you for the question. So now I'm going to move on to CAD. I can answer more questions about it in the breakout room, but I'm mainly going to be showing you how to add a logo to a file so you guys can customize your things. I did so for 2 of the schools. I'm not sure if they're on right now, but I did one for Tomball High School. You can see that it has the name and one of the logos, and then there's also a logo over here. A nice, I think it's a panther. I could be wrong though.
Claire, I do think both teachers are on, Jessica and Stephanie from
Oh.
Tomball and Allen Academy. And we did print for them and deliver in Houston. And they can speak for themselves, but they were excited and they really appreciated the work.
So yeah, you guys can, we got them these, neither of them have printers. So if you don't have a printer, we can work around that. But if you do, you can make edits on your own and then print it. You can see that it's slightly extruded from the side. So when you print it, you have a little logo and it's just really cool and it can make you feel more part of the project. And it's fun to show people that you have a customized the product. Same thing for Allen Academy, the nice Ram with Texas. So I'm going to show you guys briefly how to do it. I can answer more questions later. There's 2 main ways I have found. The first and easier way is to take a PNG or a JPEG and convert it to a file called an SVG. I just do that through an online website and then I download the SVG. There's different CAD softwares. I'm using Fusion, but I would assume most others can do the same thing. There will be a section where you can insert an SVG. I'll insert it from my computer. I have it right here. We're going to be doing a rocket. You're going to have to probably scale it down. This one, if you can see it in the bottom corner, is very big. So we're going to have to make it much smaller for it to actually fit on this. So we'll go 0.1. Heck, we might even have to make it smaller. This is a very big rocket. Okay, I'll make it even smaller. Okay, that's a good size. So you would place an SVG. I recommend doing CADing with a mouse. It is easier with a mouse rather than a touchpad. So this is a successful SVG. I have tried it with other JPEGs and PNGs, and it is not nearly this clean. Which is why I'm going to show you a second method. It's much easier and faster if the SVG works like this, because all you got to do is click OK. You'll see that it shows up. You can see the green outline. I'll click Finish Sketch. And again, I'm using Fusion, but I assume most softwares have some sort of toolbar up here. I use Extrude. I click on the stuff I want to extrude, so it'll select the sketches. You can see them getting highlighted in blue. I come over here, I click join because you want it to be a part of the same thing, the same component. If you click new body, I think it would still print fine, but I think it's better to click join. And you can always look up the difference between join and new body and new component. So I put a certain amount, I go with 0.05 and lost my mouse. I click OK. And sometimes, depending on the complexity of the logo you are doing, it may take a second to load. I'm hoping Fusion will work with me here. There we go. So you can see now, you can see that there's an outline in black, but now you can see that it's slightly raised away from the surface. So when you would print it would print like that. So I'm also going to show you a quick, well, depends how complex your thing is, but if the SVG does not work, you can also do it. I have found, and this is what I had to do for Allen Academy and Tomball High School because their logos were too complex for the SVGs that I tried to create. I insert it as a decal. So that you can do with a JPEG or a PNG as far as I know. You click open, you select a face, We're gonna have to make it smaller again because these things usually start pretty big. So you can see there the rocket, and it's colored because it's a decal. So this is not what we're going to be showing. Let me turn on decal so you can see it. So we see it, we go to sketch, we click on the same face, it decides to rotate. And then you're gonna trace along it. I'll try to make this pretty quick so nobody gets too bored of it. My favorite sketch tool is this Fit Point Spleen because it's really good for making curved lines. You guys can see the green lines starting to appear. And you guys can make these as complex or as simple as you want. As long as you have a sketch to extrude, it should work the same. I recommend trying SVG first. It will usually take less time because you don't have to go through and trace it all out. There's also, if there's a regular shape like a circle here, you can click the circle tool and then it's really quick and easy. Bam, I made a circle. Bam, I made another circle. And a third circle. And now all that's left are the fins, which we'll do quickly just so we have a complete rocket. Click that. And there's different tools that you can use, like I said, for doing the sketches. While Fit Point Spleen is my favorite, some people may just prefer to use straight lines, and it depends on what you're trying to trace out. You want to make sure that all the lines are connecting. If your lines aren't connected, then it won't extrude properly. There's also some more tools here. Offset, I won't do too much with it, but it is useful. You can see that it makes the same shape, but is slightly offset. So then you could just raise like this line rather than a whole face. But for now, I'm going to leave it like this. And you can ask more about the offset tool in a little bit. Same thing as the SVG. Now that we have this, I click, well, I'm going to turn off the decal so we don't have to get too confused by it. You click extrude, you click on the stuff you want to extrude. I'm going to extrude this stuff. You click join, you add the distance, click OK. Gonna have to wait for it to load a little bit. A couple other softwares I know of are Tinkercad and SolidWorks. Onshape is an online website, I think, that you can also use. But as you can see, it is now also raised. It looks a little different than the other one because I sketched it differently, but you can see both of them are still raised rockets, so that could be your guys' logo for your school. You can also easily do text. I didn't show it, but I won't show text, but you can easily add text. There's a tool right here. And you do the same thing as the other stuff when extruding. You click extrude, you select it, you put a little distance on it, and it will look the same. That's how we got to Allen Academy and Tomball High School. You can see that the words are right there. So that is the end of the CAD. I'm not going to show you guys now, but there is another step after you design stuff in CAD. You have to export it, usually as an STL file, to a thing called a slicer. We are currently, or I am, and a couple other people are using Bamboo Lab as our 3D printers. We found that they're very good. They're very smooth. They have their own slicer, and you would put the file in there. I can talk more about that in the breakout room. And then once you slice it, that's when you can put it on the 3D printer. You click print, and barring any issues with the 3D printer itself, you will then have a finished product like this. Well, finished, unless you need to do more finishing. But for what we're trying to do, this is currently our finished product. You can see some in Mrs. Pore's camera. They have a couple on the table. They have tree supports there as well. Those are very useful, but I will digress on that. And that was a lot of info. I'm happy to answer some questions now, but I will also take questions in the breakout room, and I'm happy to explain more about what I just said or talk about anything else 3D printing.
Claire, what a great job you did. Thank you so much for the presentations. I did want to highlight the fact about getting your name on it for the participants at the school, that is a valued part of belonging to the mission, as us, well, creating the mission within our school and adding names to one panel of the mentor teacher, maybe the students all working on it. So on ours, we have like 8 or 10 names, but the idea for us was to capture this goal to get our fingerprints in space, our signatures in space, our names on what we're making, to just make it more real. So the text tool, I want to encourage people to use these as models and teaching tools. And the people that are working on it and creating the models, it's unique to add on terminology meaningful for your school. Claire also put 2 different versions that we have enjoyed using. One is a half scale version where we're printing half size. For many reasons, that is just as teachable, takes less print. But we also had the idea of gluing together the parts, and Stephanie and Jessica have received those, where we make the full model where it looks like the actual 3U CubeSat satellite. And what comes with the files is the launcher that our large satellite will go in. So they're able to see that fit and form. And that is actually the part that we're putting these logos and names on. It's the outside P-Pod CubeSat launcher. Did I say that right, Garth? We have to be careful about the words we will use together as a mission team so that we're all talking about the same thing. And our 3U satellite will have these SlimSats within it. So we'll have satellites within our larger satellite. All right, so Claire did a wonderful job, Garth, and she did it under the time. So are there any questions right now that you know the group would benefit from? I put Dr. Jha's name in the chat, and I'm now just looking at this. If any of you do not have access to a printer in your area, please let us know. We will want to help empower you with a model. But the greatest part is having this for your campus. Claire shared a model, one of the 2 models that we're using here, just a really good best practices of sharing what works in our labs. It has 2 different kinds, allows for this kind of printer that we have versus the one I use for my classes. It's just a newer model and goes a little faster. But there's all sort of tips and tricks if you haven't been 3D printing much about not using old filament, protecting it from sunlight. So I think that maybe we'll have an ongoing breakout group for CAD in the future for anyone that wants to be using it. All right. Garth, should I go on to the next thing?
Yeah, sure.
All right, so I have a product to show you. We're playing around with colors and words, and we want to encourage everyone to join the mission patch design for your campus. So this is one version of our patch. It has some final updates, like we think it's important to put your city and state so people are aware of what school. But we also have symbolism in ours. So I'm going to hold it up again, but I want to tell you what you have to watch for. If you haven't done one of these before, there is a thread count limit, and the bigger the patch, the more expensive. So circles are cheaper. That's what I've learned. The number of colors you use makes it cheaper too, if you could stick to 3 or 4 colors. And you're not able to get so many details. Like this would print as a sticker, but I'm not sure all those details will come out on the thread count. We have the solar panels of the International Space Station around our Knight, because we are the O'Connell Knights, and those represent our launch. Way in the back, you can see a 3U CubeSat. We have a DUCS acronym that is just personal to our group, about wanting to develop universal CubeSat knowledge for other students. We like the duck for different reasons. We need to be a duck and let a lot roll off our back. But it is also a useful physics tool in neutral buoyancy and a 0G indicator for parabolic flights. So we enjoyed creating our mission patch to represent all the parts O'Connell has, which is joining with students across the board, which is you all, and representing our school. So we are thinking about making a second patch just for our satellite slice. Originally, we had a satellite name called Space Toast for one of our previous satellites. And we are bringing to you brainstorm ideas that you can have your satellite named. You can put that on your launcher. You can make it a story. So one of our Space Toasts was created as an inaugural mission at the high school level to tell a story. It was had a little bread shape around it. And these units are the size and shape of a piece of bread. And the story for it was, at O'Connell, we're bred for this stuff. They are put in, loaded into a deployer that looks much like a loaf of bread. They are toasted during thermal vac testing, and they are burnt toast, hopefully upon re-entry into our atmosphere to clean up and not cause any more orbital debris. So our symbolism, I think that you would want to include would be anything that, like, our school has certain unique parts of our building that might be beautiful to represent, or like a star on the world right where your school is. So however you want to do this, I found much power in creating a mission patch for my satellite launches, to tell the story, to make it physical, and to help keep our team together. And the best start of it was building a mission patch together that told our story. So on the back, this was the other idea, and I had a few opinions from it at this teacher conference, but we did want to offer some words on the back that was universal and bonded us as a big mission crew for the CAPE-Twiggs mission. We put crew member on the top. We thought that was kind of fun. But this is the favorite idea that we have right now. And some of you, I know that you're very aware of how to do a mission patch or a design. But we did want to offer you all, in an email follow-up like we did before, a document that will have about 8 or 10 lines of text that you could use on yours. It will have the CAPE-Twiggs mentioned in case you want to have that on your patch. We do have it in the center. We have CAPE-Twiggs right there. You do not need permission to add that. No one's allowed to put NASA logos on patches any longer. But other than that, it's free design. I suggest you use an AI designer as well as student art. That helped move us to our final patch. Does anyone have anything to offer? Garth, have we been covering agenda appropriately?
Yes, we have.
Okay, good, we're early.
Yeah, that's great. Does anybody have anything to say or have any questions, generally speaking? If not, I'm going to go ahead and open some breakout rooms, and if you'd like to talk with Dr. Darby or Claire, please put in the chat who you'd like to talk to, and I will move those people to those rooms. I'll move the speakers to their rooms. And if you have trouble going into a room, please let me know and I'll move you specifically. And then, so Claire's going to talk about CAD, and Dr. Darby will be available for any conversation or questions you might have for him as a professor and PI of the CubeSat project. And if you used the Deep Scan Network activity, or if you use the JPL activity and you'd like to talk about that and ask questions and just tell us how your experience was, you can stay in this room. And so if you'd like to specifically talk to Claire, Dr. Darby, please put a comment in the chat. And otherwise, we will stay here. So did anybody do the JPL or the Deep Scan Network activities?
So I want to reinforce that small group after school exposure to these activities is right what I was expecting would be a good comfort level. I had a few talks with 3 of these teachers out here. I was able to try it in my bigger classroom, but if you haven't tried any of these, not to worry at all. The main purpose is to roll them out so they can be in your toolkit. You are going to be amazed about this next presentation next month. It is so incredible. Just going around in a live platform that tracks orbital debris and how you can calculate how much it would cost to remove it and look right above your own school and imagine predicting orbital collisions. And you can fast forward in time. That's one of the really special options of some of these things we're bringing to you all, is a different way to think about teaching. We have coming also to you a slide set about the 4 types of satellites. We've been working on it for a while in conjunction with another university. And I think that's the most precious things that I can offer to you all, are those things you can't find easily. So that I just finished up yesterday, and I will share that over the next month. Garth did mention that we're not sending out hardware kits yet. We are, I think Nick is on, but they are working on it every day. Right, Garth? That was the update. So they're not going out this month. Please consider a way to gather your students and let them listen next time. This will be a really very unique opportunity to have this private time with Dr. Jha. He will be readied with our latest meeting. I'm going to let him know how this went. He just announced on LinkedIn that he's writing a book about his experiences. So his TED Talk is amazing. He has a couple of them now. And I'm very lucky that he likes our mission. You all are going to be the winners of it. So I just can't wait for you all to hear it. He doesn't give more than 15 minutes to groups. He said he has 30 minutes. So please try to come on time. We'll give him the first 30. And then I expect he might mention the activities that I'm going to share, but I will give them after the talk. There's like a basic training, kind of a target sheet on using it for the first time. And then there's a story that goes with it. And it's an invitation from Dr. Jha and our mission team to take it on. So using real tools in the industry makes me very excited for our mission members. And that is what Fusion is, what Claire just showed you all. So if you don't have Fusion or CAD going on in your classroom, almost all of them do unlimited, as long as you renew it every year, for teachers and students. I have not found anything that has limited students to renew their CAD license. So shall we go to breakout rooms, Garth?
Yeah, we're already doing breakout rooms.
Okay, they're there.
If we're talking about CAD 3D design, that's what we've been talking about. But computer-aided design can also be used for PCBs and circuits. And so what we use is Altium Designer. And if you want to get your students into circuit design or PCB design, Altium, A-L-T-I-U-M, Designer offers licenses for students for free. You just have to sign up through their website, through their education program, and they offer Altium Education, which is pretty robust videos and training on how to use Altium Designer, and that's an industry standard PCB design software.
That's cool to know, Garth.
A lot of different features there.
So to tag on to that circuitry and electric circuit design, last week at my SEAT conference, I learned about another aspect of a virtual platform I already use. MakeCode.com has a circuit playground, and it was really a great way to show a beginner how to turn on the LED light with just a virtual circuits. It has a $30 component that you can make live and test it. But I think to scale all of this for our groups, we need to know like the ladder, the first ladder step you go on, but then all the way up to industry. So Garth, that's really cool to hear. At Adafruit, that we also call Adafruit, that also hosts the circuit playground and makecode.com. And I was excited to see Adafruit becoming more popular in the education field, because that is what we have been using with our hardware. And you all will be more familiar with the Adafruit once you get your kits. So Circuit Playground, it's like the fun Friday thing to introduce to students.
And so I guess we can go ahead and wrap up. Thank you everybody for coming to our meeting today. Our next meeting, we're going to have a guest speaker, and please invite your student teams. If you listed your students' emails when you signed up, then we'll automatically send out an email to them. Otherwise, share the email with them, and we'll send everybody a follow-up email from this meeting. And so, thank you.
I'm going to stay on a few minutes. I'm going to stay on a few minutes, Garth, if you don't mind.
Same here.
Okay. And thank you for your time.